Alright, so today I'm going to be doing the final review. Teach It, I was assigned number 31 on page 528, and it is a student reasoning problem. So the problem says, Melissa was tossing a quarter to try and determine the probability of getting heads after a certain number of tosses. Jennifer says, you've got 5 tails in a row. You're sure to get heads on the next toss. Karen says, no, she'll definitely be getting tails. So what they're wanting us to answer and analyze is to explain the reasoning and do you agree with either student. So to start with, we're going to be looking at independent events, just reviewing it. So independent event means that each event is not affected by another event. So in this case, it's going to be like tossing your quarter. So we got heads and tails. Heads and tails, tails, heads. So what this is proving is that that a coin, you can think of it like this, a coin doesn't know that it came up heads or tails the previous one, so each toss has the same probability as the next one. So it doesn't matter if I've flipped this coin, 100 times, it's still going to have the same probability the next time I flip it. This is going to be the same with something like a die, which I, for some odd reason, don't have in my house, so we're just going to visualize it. So, say you wanted to roll a number 3. Each time you roll the dice, you're going to have the same probability as if you were to roll it in 5 minutes. It's never going to change. It's independent events. Same with if you have these Legos right here, and you put them in a bag, the probability of pulling a certain color is going to be the same no matter how many times you do it, what time of the day you do it, it'll always be the same. So if you put these all in a bag and say you want to draw the blue one, and there are 6 of them total, you're always going to have a 1/6 chance of pulling this blue one. It doesn't depend on anything else. So with that, we're going to be looking at the probability formula. So the probability formula is the chance of an event happening equals the number of ways it can happen over the total number of outcomes. So for the chance of getting ahead, how many ways can it happen? Well, there's only one way you can get ahead, and that is tossing it and landing on a head. So that would be one way, and the total number of outcomes you could possibly have would be landing on a head or landing on tails, which would be 2. Same thing with down here. So your chance of getting a tail, you have 1 chance if you flip. There's only one way to get a tail, and you can either get a tail or a heads. So same thing, you're going to have 1 out of 2 chance, which is going to be 1/2 chance, which goes down to 50% on each. Okay, so no matter, like I've been saying, no matter when you flip it, how many times you flip it, you're always going to have a 50-50 chance of getting heads or tails. So, going back to the problem, so something that the girls were talking about was, let's see. So the way the girls were wording their statements that you've got 5 tails in a row, you're sure to get heads on the next toss, or no, she's definitely going to get tails. What they're referring to is something called the gambler's fallacy. It's something that we also learned about in class a little bit. It's the thought that an event is overdue or bound to happen. So, like I've been saying throughout this Teach It, it doesn't matter how many times you're going to flip this coin, you're always going to have the same probability. So just because you flipped it 5 times doesn't mean that it's bound to happen on the next time. Every flip is an independent event, so you just have the same probability as you did the last 3 times of getting a heads or tails. So with that, to answer the final question, do I agree with the students? No. Since each toss has the same chance of being heads or tails, nothing is bound to happen just because of the previous events. So this wraps up the Teach It for the final review number 31. If you have any questions, you can definitely post in the discussion below, and I'll be happy to answer them. Thanks, guys.